Hello Year 5 and welcome to this instalment of our science unit, and the lesson objective today is to understand different types of radiation. So just to begin with, can we write the lesson objective and the date please, and the starter heading to begin with. So just pause the presentation here and do that before continuing. Right, so let's have a little look at our starter task. So think back to last lesson, and can you remember what makes an atom unstable? Which one of these atoms would you describe as unstable and why? So we've got atom A, atom B, and atom C. And can you do that underneath your starter task? So can you give me a description, just a sentence of which one of these atoms would you describe as unstable? So pause the presentation here and spend about 2 or 3 minutes writing that sentence. Right, let's have a look at the answer. So can you mark with your purple pen, please? It would in fact be atom A which is unstable, and that's because atom A is classed as unstable as the forces within its nucleus are imbalanced. And can you remember why? It's because there are more neutrons than there are protons in here. The number of protons, electrons, neutrons are not the same, so it's imbalanced and therefore it's unstable, as the atom is spending a lot of energy trying to make all of these subatomic particles equal, and therefore the atom would be balanced. So nuclear fission and radiation. As atoms are being split in nuclear reactors, which we looked at last lesson, this creates a huge amount of energy. Now, nuclear fission, remember, is the splitting of the atom. So here's our diagram to remind us. Now, these unstable atoms and nuclei are released, and so is a lot of heat and radioactive material. So during this reaction here, not only are new atoms and neutrons released, there's also a lot of heat and a lot of radioactive material and radiation given off. This radioactive material is a byproduct of nuclear fission. So a byproduct is when something is made incidentally during the process of making something else. So radioactive material is not intentionally made here. It's just made sort of as an addition to the reaction itself. Radioactive material gives off radiation. So when a radioactive material is released, it gives off something called radiation. We're going to find out what radiation is. So radiation, we're going to look at how radiation is emitted during nuclear fission. So remember, nuclear fission was the splitting of the atom. Unstable atoms are always trying to become stable by emitting some of their particles. So that's why unstable atoms have higher energy, okay? Because they're always trying to get rid of one of those extra neutrons or protons in their atoms. So when an unstable atom emits these particles, this results in radiation. So here we have radiation can come in the form of alpha particles, beta particles, and gamma rays. So when an unstable atom splits into two more atoms and releases the neutrons, it also releases this radiation, these types of radiation here. Okay. Right, now radiation and different levels of penetration. Now, radiation can get through the examples of radiation that we've seen can penetrate and pass through different thicknesses of matter, okay, depending on what type of radiation they are. So they're capable of penetrating different materials. So here we have paper, aluminium, and thick lead. And here we have our examples of radiation. We have alpha particles, beta particles, and gamma rays. Remember, these are all released during nuclear fission and the splitting of the atom, okay, in the nuclear reactors, which we've been learning about. So all the examples of radiation get to paper. Now, alpha particles are stopped at paper. Paper can stop alpha particles passing through. Alpha particles can't really pass through thin substances at all. whilst beta particles and gamma rays can pass through paper. And then we get to aluminium. Aluminium and the thickness of aluminium can stop beta particles, whilst gamma rays can pass through aluminium, and then they get to thick lead. Okay. Now gamma rays can stop at thick lead. Now if depending on the thickness, some gamma rays could even pass through, but most of the time a lot of thick lead will stop gamma rays. Okay. So here we can see that some dangers can be posed by these different levels of radiation. And can we think of what dangers could be posed? So this is where the task comes into play. Okay, so first of all, I would like you to draw our diagram here, showing what levels of thickness of materials can stop each examples of our radiation. So draw the diagram and then think, which two types could cause us problems and why? If humans are exposed to high levels of radiation, which two types could cause us problems and why? Why and how do you think it could harm us? And which type of radiation will be safer and why? So first of all, draw this diagram, then answer these questions. I'm just interested in what you think, okay? So pause the presentation here and I want you to spend around 20 minutes on this task. Right, now on to our answers. So can you get your purple pens out? And first of all, you should have drawn your diagram like so. And the answers, now they don't have to be exactly the same as mine, but they could be something similar. So number one, beta particles and gamma rays could cause us problems as humans, as they could penetrate our bodies. Now, our skin isn't as thick as aluminium or thick lead, so beta particles and gamma rays can get into our bodies and harm us if we were exposed to high levels of radiation. Number two, beta particles and gamma rays could break up and harm our body cells. Now, that's how they would cause us damage. They get into our cells and they could break them. And number three, alpha particles are safer because they can't penetrate our bodies. Now, our skin is thicker than paper, so alpha particles can't get inside and break up our body cells. Now, we've found out what types of radiation are given off during nuclear fission, okay? But what is radiation, you might ask? Now, radiation occurs naturally and as a form of energy. Remember, radiation is emitted by unstable atoms. Now, in a nuclear reactor, those unstable atoms are in high concentration. There's a lot of them in one place. But remember, unstable atoms, they exist naturally as well, so in the world around us. Radiation can travel through different mediums, as we've found out. And radiation is all around us and we're exposed to low levels of it every day. So remember, radiation occurs naturally and is something that it surrounds us on a day-to-day basis in low levels, and these low levels are harmless to us. Radiation is emitted by unstable atoms, remember, which are found naturally. But also remember, in the nuclear reactor, there is a lot of unstable atoms in one place, and that's why that can be quite harmful in one place. What do you think could give off radiation in our day-to-day lives? Now, I just want us to put the heading, the quick task, and can you think of anything that could give off radiation in our day-to-day lives? Just spend 2 minutes making a very quick list. I'm more interested just to see what you think, really. You don't have to get these correct. So pause the presentation here and just spend 2 minutes thinking of what could give off radiation in our day-to-day lives. So everyday radiation. Now let's see if anything on this slide compares, how things on this slide compare to something that you might have written on your quick task list. So radiation is all around us and very low, harmless amounts. So whilst in a nuclear reactor during nuclear fission there is a large amount of radiation in one place, everyday radiation occurs naturally and is in very low, harmless amounts. So, first one, the Earth. There are some unstable atoms made up in the soil and the earth around us which emit radiation. Same with food. Food contains unstable elements which emit radiation. Outer space. Now, radiation can pass through any or lots of different materials and mediums. So radiation can travel through from outer space and into our atmosphere. Buildings and building materials. Air travel. Lots of unstable atoms are given off during air travel and emit radiation. And the last one could be hospitals. Now, can you think of anything that in a hospital which would use radiation? Have you ever heard of anything? And we'll come on to this later on in our unit, and we'll focus more on this little section here. Now, when can radiation be harmful? So we've touched on it slightly earlier on in our lesson. Now, radiation can become harmful when there is a lot of it in one place, like we've seen in our nuclear reactors. Now, we've seen Homer Simpson panic a few times on The Simpsons when his nuclear reactors are in trouble. And remember, radiation is energy, and lots of radiation in one place can be harmful if not controlled. So nuclear reactors, where atoms are split, or nuclear fission as it's known, control this radiation by disposing of it securely. This is called radioactive waste. Right, now, a little task that we can do about radiation. So using the information that you've learned today, create a fact file about radiation in your books. You can use diagrams, labeling, or sentences to explain your fact file, and feel free to use colours to bring it to life if you want. Now, key points that you could think about is: what is radiation? What kinds of radiation are there? What do they look like? What everyday sources of radiation are we surrounded by? And where could we find harmful radiation? Now, you don't have to address all of these points. I just want you to spend around 10 or 15 minutes thinking about and writing about or explaining what we've learned about radiation today before spending 5 minutes on our plenary at the end, okay? So pause the presentation here and create a mini fact file of what you've learned about radiation today. Now, our final task of the day is to consider the implications of nuclear power. So we've been investigating, haven't we, in English and humanities, in addition to science, sort of the implications of when things can go wrong at a nuclear power plant, or when radiation goes wrong. So around 10% of the world's energy is produced in nuclear power plants. And the splitting of the atom, or nuclear fission, creates energy which is changed into power. And the splitting of the atom also creates a lot of radiation, as we found out today. Now, do you think it's worth the risk? Knowing how dangerous radiation could be if not controlled, do you think it's worth the risk to create this power? Okay, so underneath the heading plenary, can you write a couple of sentences of whether you think it's worth the risk to create this power? Okay, so this is something that we'll address next lesson as well. So can you please just pause the presentation here, spend a couple of minutes giving me a couple of sentences of what you think. And then that's the end of the lesson today. So thanks very much for tuning in, and we'll speak with you next week.